What we will do in this video is to give you a background about the three clustering algorithms, namely k-means, hierarchical, and dbscan. And afterwards, I will also introduce you to classification algorithms. These are the optimizable KNN, naive Bayes, and fine tree. And we will use a confusion matrix to validate the true predicted data and the incorrectly predicted data. Okay, so let's start. So my data is from the Kaggle website. So let's import this now by going to the Home tab and select the Import Data. So let's choose the penguins. So this data set contains all the measurements of a penguin, including the species of the penguin. So basically it has three species, the Adelie, Gento, and the last one is the Chinstrap. Okay, so it has also these columns, the island where it can be found, together with the sex of the penguins. But I will be selecting only those columns that I think meaningful for clustering and classifying the breed of the penguin. So for now, let's start selecting the measurement of the penguins by selecting the column B up to column E. And then we have to deselect those rows that does not contain meaningful values, like the row number 5. Okay. Okay, so I've already selected the measurements, so let's import this as a column vector, or probably much better if it will be a numeric matrix. And then import this one, and we have now the penguins. So next is we have to rename this. Rename this to penguin measurement, or just PMES. And then let's go back to the import data window, and then let's choose the first column for the species of the penguins. So let's choose this one, and then deselect the first row. Then let's import this as a column vector. Then import, there you go. And we can call this P species. Okay, so let's rename this one and call this P species. So I have already separated the classification labels and the measurements of the penguins. So now let's look into the scatter plot of each column that we have for our data set so that we can compare which column combination that can give us a good prediction for our query data. So let's start with the bill length, followed by the flipper length, and the last one, the body mass. Figure number 1 shows the scatter plot of the bill length over bill depth. And figure number 2, it shows the scatter plot of the bill length over flipper length, and the last one is the bill length over body mass. So from this scatter plot, I chose the column 1 and column 2, which are the bill length and bill depth. Okay, now let's move to the clustering algorithms, and let's start with the k-means clustering. And let's see if the result of the k-means clustering is the same as with the results that we got from the true clustering from the scatter plot that we had a while ago. Okay, so this time we had a k-means, setting the k with the value of 3 because we believe that there are 3 groups in our data set. And then we display the result of each iteration, and then we use the Euclidean distance for measuring the data points in our data set. And after that, we display the scatter plot, and we add some label on it using the type 1, 2, up to 3. Let's try running these lines and see the result. So this is the result of the k-means clustering algorithm. If we are going to compare this to the previous clustering, it is somehow resembles to the exact clustering that we got from the G-scatter plot just a moment ago. The figure 2 is the true clustered data, and the figure 1 is the clustering result from the k-means. So it was able to somehow predict the exact result. So the blue ones here are those yellow ones in the k-means. The red ones are a bit mixed up with blue ones, but I suppose this is very close enough to the true clustering of our data set. Now let's look into the clustering of the DB scan. So let's go back to our editor and go to our DB scan. In the DB scan, I use the estimate epsilon with a minimum points of 8 and a maximum points of 3. And I also use the Euclidean distance for measuring the distance of the data points. And let's try what is the effect of this. Let's run the lines for the DB scan. So for the DB scan, it was able to identify that most of the data points are in one cluster. And the blue ones, the blue dots, were indicated as outliers. Okay, so let's move to the hierarchical. So this is the clustered data for hierarchical. And we supply it with max cluster of 3 because we believe that we have 3 groups and the linkage was set to average. Okay, so let's run this. So there is a good clustering on the points of yellow, but for the red, it was able to combine those data points from the blue ones and was identified as red cluster. So if you're going to compare this to the original clustering, there should be at least 3 groups, and the clustering of yellow was actually a bit accurate, but for those yellow in figure 2 and those red dots on the figure 2 were clustered by hierarchical as one cluster. So I suppose from this result, I can say that the k-means clustering has the best result. Okay, so let's now move to the classification algorithms. So let's try training an algorithm using 3 classification algorithms, and that will be the fine tree, the optimizable naive Bayes, and the optimizable KNN. Okay, so let's minimize these figures, and we will use the app learner. So let's open the classification learner. Let's start a new session from the workspace. We select the species or the PMS, and then we choose the from workspace, and then we select the P species. We're only interested in columns 1 and 2, so we will uncheck column 3 and 4. And then we will set aside 30%, and we will only use 70% of our data. So let's start the session and wait for it to finish. We have now the scatter plot of the fine tree, and we also have this summary telling us that it has used a maximum number of splits, 100. And let's start training our data using the fine tree by hitting the train all. Okay, so this is now the validation matrix telling us what are the properly predicted and improperly predicted. So it has a prediction of 104 correct prediction for Adili, but it has 7 that was identified as chin strap. Okay, so let's proceed training some other models by selecting a new classification algorithm. So let's try using optimizable naive Bayes, and let's try another one by selecting the optimizable KNN. And let's train them all. Okay, so the MATLAB has already finished training all the algorithms. So for Find Tree, it was able to produce an accuracy of 91.7%, and for optimizable naive Bayes, there is 92.9%, and for the KNN optimizable or optimizable KNN, it has 94.6%. So from these three classification algorithm, let's choose the algorithm that produces the highest accuracy, which is the optimizable KNN. So let's choose this one. Then let's export the model. Export the model in our workspace. We select the first option and we will name this MDL70 and OK. So after creating the new model, we have now this MDL70 optimizable KNN model that we have trained just a moment ago. So now let's use this trained model that we got using the entire dataset of our penguin. So first thing that we need to do is to separate the first and second column and assign that to the final X. Then the second step is we will predict the labels using the final X. The Y fit is the predicted labels from the final X using our model from the optimizable KNN, and the Y test are the true labels, the true classification labels. Okay, so after doing the prediction, we will see a confusion chart for us to see how does the prediction goes using the optimizable KNN. Okay, so let's run these lines, and there is now the result. So it was able to predict most of the data points except for the Adili, we have one incorrectly predicted, and for Gen 2, we have two incorrectly predicted. So the next thing that we will do is to add noise to our original data. In line 86, our original data is the final X that contains the bill depth and bill length of the penguin. And then we will generate a random number based on the size of our true data. And then from this line, we generate 5% noise and then add that noise to our noise variable. And then we predict those data points from our noise and produce a classification label from it. And then compare the result by using confusion chart. Okay, so let's try running these lines. Okay, so this is now the result that we get from the actual class and the predicted class. So basically there are 303 correctly predicted out of 342. So I suppose that there is a significant effect after adding 5% noise to our true data. So this ends my demonstration on the classification and clustering algorithms. Thank you for listening, and bye-bye.